In this presentation, I'm going to explain how to write a program to multiply two matrices. So let's get started. We want something like this. We want to ask the user to enter the rows and columns of matrix A, and user will input some values and we have to store these values somewhere. After that, we will ask the user to enter the elements of matrix A, and then we will ask the user to enter the rows and columns of matrix B, and we will ask the user to enter the elements of matrix B. Finally, we will calculate the resultant matrix by multiplying these two matrices. Okay. For better understanding, I'm going to divide my program into three parts, and here are those parts. In part 1, I will explain how to ask the user to enter the rows and columns of a particular matrix. In part 2, I will explain how to ask the user to enter the elements of a particular matrix. And in part 3, I will explain how to calculate the resultant matrix. Let's see part number 1. As I told you in part 1, I'm going to explain how to ask the user to enter the rows and columns of matrix A as well as B, and how to store these values which are entered by the user. For this purpose, I will take a matrix A. Because I'm here taking the example of a matrix A, the same procedure will be applicable for the matrix B also. Okay. Here I'm taking matrix A. Also, I'm taking two variables, A rows and A columns, where I will store the number of rows of matrix A and number of columns of matrix A which are entered by the user. Okay. In the printf function, we will ask the user to enter the rows and columns of the matrix A, and then we will take the inputs which are entered by the user inside these variables A rows and A columns for matrix A. Okay. For matrix B, this will change to B. This will also change to B rows and B columns, and similarly this will also change to B rows and B columns. Okay. Let's see part number 2. In part 2, we will ask the user to enter the elements of matrix A and B. I will explain this process for matrix A. The same process is applicable to matrix B as well. We will first ask the user to enter the elements of matrix A, and with the help of two for loops, as we already know, we can input the elements which are entered by the user inside the matrix A. This is very simple to understand. I have already explained this process in the previous lectures, so it is not very difficult to understand. Okay. Now let's see part number 3, which is the most important part. That is to calculate the resultant matrix. This is our resultant matrix we want from these two matrices. Let's see how we can calculate this resultant matrix. For this purpose, first of all, we require one array which will store the values of the resultant matrix. Okay. And then we will require one variable called sum, and I'm initializing this sum to 0. Now recall the process which we have followed for the multiplication of these two matrices. First of all, in order to calculate the first element of the resultant matrix, we have to take the first row from this matrix and first column from this matrix. That is, we require two for loops for this purpose, which will keep track of number of rows from the first matrix and number of columns from the second matrix. Apart from this, we know that we have to take one value from here and one value from here. In order to take these two values, we require just one for loop. Because when we are traversing the first column of this row, we have to simultaneously traverse the first row of this column, right? And then if you recall, after multiplying these two values, we have to take these two values. This means when we are at the second column of this row, then simultaneously we are in the second row of this column. Therefore, a single for loop is required to keep track of this. Here I am taking B rows. You can take A columns also. Because we are traversing the columns of the matrix A, and simultaneously we are also traversing the rows of the matrix B. And number of rows of matrix B are equal to the number of columns of the matrix A. Therefore, we can take B rows or we can take A columns. There is no problem. Now, inside this for loop, this statement is required. Sum plus equals to AIK into BKJ. What does it mean? Index I indicates the row number of matrix A and index J indicates the column number of matrix B. Initially, we are in the first row of matrix A and first column of matrix B. Here we are taking the K because we have to traverse the columns of this row one by one, and simultaneously we have to traverse the rows of this matrix one by one. For matrix B, we are taking K over here, right? Now let's see how it actually works. When I is 0, J is 0, K is also 0. That means all these indexes are 0. We are in the 0th row and 0th column of this matrix. That is, we are taking this element. And in matrix B, we are at 0th row and 0th column. That means we are taking this element. We will multiply them together, and then finally we will add this with the sum variable. Sum variable initially contains value 0. Therefore, the result will be 1 only, which will get stored inside sum variable. Then after that we will increment the value of k. K now becomes 1. Will come inside this for loop. And now we are in the 0th row and first column. That means we are taking this element from this matrix. And as k value is 1 and j is 0, we are simply accessing this element from this matrix. Which means the next values which will get multiplied are 2 and 1. 2 into 1 is 2, so 2 will get added to the sum. Sum previously contains value 1. Therefore, 2 plus 1 is equals to 3, which will get stored inside some variable. Then after that we will increment the value of k, and then again we will check this condition. Condition is satisfied. We will come inside, and this time we are simply accessing this element because this element is at the index 0, 2, right? Here also it is 0, 2. And from the B matrix we are accessing this element because this element is at index 2, 0. That is, here also we are having 2, 0, right? This means the next elements which will get multiplied are 3 and 3. 3 into 3 is 9. Therefore 9 will get added to 3, which was the previous value of the sum. 9 plus 3 is 12. Therefore sum will contain value 12. And this is the value that we want. And now we have to store this value in this product matrix. Therefore the next step is to store this sum inside product ij. That is product 0, 0. That is in the first row and first column. After that sum will get initialized to 0 and the same process continues. Now let me combine all these parts together and execute the program. Here is our actual program, and here we can see I'm asking the user to enter the rows and columns of the matrix A, and then I'm asking the user to enter the elements of matrix A. Similarly, I'm also asking the user to enter the rows and columns of matrix B. But there is one change over here. I'm also adding this if-else construct. Inside this if construct, I'm checking the number of rows of B matrix are equal to the number of columns of A matrix or not. This is required. If they are not equal, then we cannot multiply the two matrices. That is why if they are not equal, then I'm printing the statement, sorry, we cannot multiply the matrices A and B. Else we will proceed by taking the elements of the matrix B. And this is what we have seen to calculate the resultant matrix, right? After that, we will simply print array elements, which is the resultant matrix. Okay. Let's execute this code now. Let's enter the values 3 and 3. Then it is asking to enter the elements of matrix A. They are suppose 1, 2 and 3. 1, 2, 1. Then 3, 1, 2. Then it is asking to enter the rows and columns of matrix B. They are also 3 and 3. Now I will enter the elements of matrix B. This is our resultant matrix 12, 9, 11, 6, 7, 7, 10, 10, 14, which we have seen in our example as well. Okay friends, this is it for now. Thank you for watching this presentation.